This video is on graphing radical functions. We're going to be rewriting a radical function into the function notation or into a format so we can figure out the transformations so that we could graph without the use of a calculator. So we want to know, how can we rewrite the y equals the cube root of 8x plus 32 minus 2 so you can graph it using transformations. We're going to describe the graph, then we're going to sketch the graph, and then we'll check our results with a calculator. So what we want to have, we need to find our a, h, and k, because the parent function, or the way this needs to look, is y equals a, then we want the cube root of x minus h, and then plus k. So we need to find the x minus h, our k, and then our a. So in this problem, we actually have an 8x plus 32 instead of just an x. So what we want to do is, if we can factor something out and then take the cube root of it, that's where we want to focus. That's where we want to start. So instead of having an 8x plus 32, we want to get just a basic x. So on here, we want to take our cube root of 8x plus 32 and see if we can change this. If we can rewrite this as something else. So going back to just understanding radicals, we can rewrite this as the cube root of, because these both are divisible by 8, we can actually divide both of these by 8 by factoring it out. And then we'll have parentheses x plus 4. But now the reason we want to see this is, going back to understanding radical multiplication of radicals, this is 8 times this parenthesis set. So really, this can be rewritten as the cube root of 8 times the cube root of x plus 4. Because if I were to remultiply this, this would be 8 times all of the x plus 4, which would come back to here. So we could re-look at this as y equals the cube root of 8 is actually equal to just 2. So we would have 2, because the cube root of 8 is 2. Then we'd have the cube root of x plus 4, because that would be 2 times the cube root of x plus 4. But then we still have that minus 2 at the end, because we never touched that, so minus 2. So now we have an a, then we have an x minus h, and then we have a plus k. So now let's just talk about what our a, h, and k are. So our a value is equal to a positive. Our a value is equal to a 2. Our h value is actually, remember, we want to know what will make this 0. So this would be a negative 4. And then our k value would equal to that, subtract the 2 outside, so minus 2. We actually have it rewritten into a format to where we can find our a, h, and k a lot easier than how it is here, which is why we did this. So now let's talk about our transformations. We know our a is supposed to be positive, so there's nothing wrong here. So that one's good. Our a is supposed to be 1, so we know we have to talk about this one. Our h is supposed to be 0, so we have to talk about this one. And our k is supposed to be 0, so we have to talk about this one. So our transformations that are happening here, a is 2, so this is a vertical stretch of 2. And then we have a negative 4 and a negative 2. So that's actually our coordinate, negative 4, negative 2. So how do we get there? We would go left 4, and then we would go down 2. So we've described the graph. That's our transformations of this. So we went vertical stretch of 2, we went left 4, and then down 2. So now we can sketch our graph. So if we come down here, we actually have our key point. Since it is a cube root, we will say our key point, again, is our h and k, so negative 4, negative 2. So that's what we would put in the middle, negative 4, negative 2. Now I'm actually going to get out 2 calculators so I can show the comparison of what we ended up having and the original. So just to make sure, So I'm going to type in the original here. So I'm going to have math. I need the cubed root of, I have 8x plus 32. I need to get out of my radical. Then I have to put minus 2. I'm not going to press graph yet. On my second calculator, I'm going to put our pink. So I have 2 math. Then I want the cube root. Then I have the x plus 4. Now this time, to get out of my radical, I have to make sure I close my parentheses because this is an older calculator. And then I put minus 2. So I have the 2 different equations, but I'm going to look at the 2 graphs. Okay, so if I'm going to press graph at the same time, so graph. And those graphs are the same, so that means that we did this correctly. Our rewritten format is correct. This rewritten format is correct. That means our transformations would be correct too. So our key point was -4, -2, so let's go find our other coordinates, and that is at around -4, -2. So -4, -2 needs to be in the middle, which it is. So now we can find the other coordinates. So above that we can do -5, -4. Sorry. -5, -4. And then above that, we can find a good coordinate. It's -12, -6. So we won't be able to graph that one, but it is good to at least have. Then I'm going to go back to -4, -2 in the middle, or at least to that one. And now I need 2 underneath it. So -3, 0 is a good one. And then let's see if we can find another one. 4, 2 is a good one. So we can graph 4, 2. So now we have -4, -2. -4, -2 is our key point. Then I'll do -5, -4. Then I'll also have -3, 0. So this does almost make the line. Sorry, make sure I get this coordinate. This makes more of a linear part, but remember, this is where it actually starts to curve. Then I cannot graph the -12, -6, but I know it'll be way over here. But I can graph the 4, 2. So 4, 2. So I know I want to connect these. And I do want to have it more of a curvature. So I know it's going to go something like this. It's going to curve. And it's going to curve again and then go this way. So I'm going to have my arrows pointing in both directions. If I look back at my graph, I have something that looks similar to it, but obviously this one is more zoomed in. So if I were to change my window to -7, your x minimum, -7, +7, then I want to count by ones. My y minimum goes down to -6. My y maximum goes to +6, and I'm counting by ones. So if I were to look at the graph on the paper, and now the graph on my screen, it is roughly the same. There is a gap here. It's because it looks more almost like it's a vertical, but this is where it's changing its curve. That's why it looks like it's a gap there. So yeah, so our graph looks good, looks pretty similar to it. And so we just created it. We determined that both of these are divisible by 8, and that's what we want. We want our x value here to be a 1. So we'll see if everything inside the radical can be divided by 8, and we'll just separate them. Because this is 8 times the x and the 4. So if I were to redistribute it, I'd get the 8x plus 32 again. But then because it's a multiplication inside of the same radical, I can separate them into 2 different radicals so that I could take the cube root of 8. And then I have the cube root of x plus 4, which would go back to that cube root of x minus h from the function notation. So this is where all that came from. The cube root of 8 is what gave us this 2. We never touched the minus 2. We never touched the k because it's not affected at all. the A and the H are what are being affected here, because I need my H to have a 1x with it instead of an 8x. So that's why we had to get that 8 out of there. But we had to take it out of both the 8x and the 32.